In step 2 of exercise number 7, the Modify Geometry Fillet option on the geometry page is used to demonstrate its effect on the iMachining toolpath. In the SolidCAM Manager, double-click iRough Main Pocket to edit the operation. The iMachining operation dialog box is displayed. On the geometry page, there is a parameter called Fillet Radius. This is a fillet radius that is applied to the iMachining toolpath. By default, the Modify Geometry Fillet checkbox is disabled, and iMachining automatically calculates the fillet radius value based on 20% of the current tool radius. This percentage is used for both iRough and iRest. For iFinish, iMachining calculates the fillet radius value based on 1% of the tool radius. The result is a smoother toolpath in tight areas and corners. Because this iRough operation uses a 12mm diameter tool, by switching the radio button to value, you will see that the conversion is a fillet radius value of 1.2 mm. The Modify Geometry Fillet checkbox enables you to apply a user-defined fillet radius to the iMachining toolpath. Using the radio buttons, either a percentage of the tool radius or a direct value can be entered to define the fillet radius. It is important to note that when using either method, the value entered must be greater than 1% but less than 90% of the tool radius. For the purpose of this exercise, enable the Modify Geometry Fillet checkbox. The Fillet Radius input field text box is open to be edited. Enter a percentage of 50, which is equivalent to a value of 3 mm. Click Save and Calculate to save the data changes to the operation and calculate the iMachining toolpath. Click the Simulate button to display the simulation control panel. Using the default HostCAD simulation mode, click the Play button to show the wireframe toolpath on the model. As you can see, the pocket is split into 3 areas, all containing a helical entry followed by the pocket roughing toolpath. Here is a close-up view of the toolpath with a fillet radius value of 3 mm. Based on the parameter of a larger fillet radius, the toolpath is limited to the larger areas of the part geometry and cannot reach the narrower passages as you can see here. Close the simulation control panel with the Exit button. Now, enter a fillet radius value of 0.06 mm, which is equivalent to 1% of the current tool radius. Click Save and Calculate to save the data changes to the operation and calculate the iMachining toolpath. Then, click Simulate to display the simulation control panel. Click the Play button to show the wireframe toolpath on the model. Here is a close-up view of the toolpath with a fillet radius value of 0.06 mm. Based on the parameter of a very small fillet radius, the toolpath is able to fit in the tight areas of the part geometry as you can see here. The tool performs a single helical entry followed by the pocket roughing toolpath. A very small fillet radius value will generally yield a longer cycle time and is not preferred for roughing. Close the simulation control panel with the Exit button. Remember, the fillet radius is calculated based on the tool radius. And if the current tool diameter changes when the Modify checkbox is enabled, you will be prompted to recalculate the geometry fillet parameter upon selecting the new tool definition for the operation. Like mentioned in the previous exercise, it is recommended to click Yes. The Modify Geometry Fillet checkbox will be disabled, and iMachining will use the default value for calculating the fillet radius. Click Save and Calculate to save the data changes to the operation and calculate the iMachining toolpath. Then, click Simulate to display the simulation control panel. Click the Play button to show the wireframe toolpath on the model. Here is the toolpath with a fillet radius value of 1.2 mm. The tool performs a single helical entry followed by the pocket roughing toolpath. Based on the default fillet radius parameter, the roughing tool is not able to fit through only this one area of the part geometry. iRest is used to remove the remaining material before using iFinish. Using the exit buttons, close the simulation control panel and the iMachining operation dialog box. Due to the data changes, the subsequent iRest and iFinish operations are no longer synchronized as indicated by the asterisks in the SolidCAM Manager. Select both operations in the CAM tree, right-click and choose Calculate from the menu. The calculation runs externally and resynchronizes the operations. At this stage, Step 2 is complete, and the Modify Geometry Fillet option was used to demonstrate its effect on the iMachining toolpath.